Hi, you are welcome to my channel Smart Polished. Here it is polished. Today in this section of video, I will discuss about the performing calculation of time series data and computing moving average and average of time series data, and it is the third video of time series. So without any delay, let's get started. So here is the data tree I already discussed in the previous section of video. Data tree is the time series data. How to create the time series data, you can go back to my previous video and let's check it there. So it is a time series data with five timed and with their corresponding values is there. Now I'm calculating their difference. Yeah, when you will get the difference, now you can do it number of multiplication on that. Time series data will give you to perform on that any additional multiplication, subtraction, divisions, or any modulo operations or diff operations, log and other operations it's allow to perform in the time series data. So you can do this thing like differences of the time series data and followed by divided the data with the whole data is also possible. You can do these things. So let's run this programs and see the output. You can do these things like this way and it will give the result as well. The same thing with that, you can do the multiplication as well. What with the previous output, with that you can do multiplication as well, or you can do the logarithm of the time series data, or you can do the logarithm of differences of the time series data as well. So far they come to the conclusion that time series data allow you to do any type of logarithmic arithmetic calculations or performing any operations on the time series data. Now you'll go for the moving average. There is a time series data how you will compute the moving average. To do this thing of the moving average, you should have to call one function is called roll mean. Roll in mean function will calculate the moving average of your data. Here it will take two argument. First argument is the data set and second argument is the which of the particulars values we will consider for to perform the moving average. Here k is equal to 2 means first values and the third values it will be considered and it will be calculated the average on that. So here moving average is calculating from there and I'm storing these values with a variable name with ma. Now you will can get this result ma at here. Ma will give a result like this way. So actually let's see the first the data how it is. Data 3, your data 3 is like this and you got the ma. Yeah, so you can see the first and k is equal to 2, so the moving average of this two. Okay, 242.45 plus 240.85, the summation of this thing and divided by 2, it is the average of 241.650. Like this way 242.85 in 240.00 and the summation and average of these two data is 240.425. You can do the calculation of like this, or you can do the alignment from left hand side as well, or you can change the ks values as 2 as well. It is depend upon to you. So let's run the program and see the output at here as well. Now we'll go for the another thing, how you'll apply a function of calendar period. So suppose there is a time series data and you want to apply any functions on that data. So how will do that thing? So apply monthly, so it will be take as a monthly, not day or not by month, sorry, not by year. It will be performed on monthly data sets and I'm transforming the data set as XTS. It will be considered as a vertical now. And the function, which is the function I'm applying at here, I want to apply the mean function at here. So let's see and see the output. So for this 3 month is actually there. First for first month 2000, sorry, 1971, 70, 71 and 72. 2 for the January month. Actually, one is January month. We will apply the mean, so we will get the result that for each of the year, this mean is like this. Okay, you can change, calculate the volatility. It is nothing but it is a changing of standard deviation with the daily log returns. Okay, So you can calculate the volatility of your data set as well. So I'm here applying this thing as monthly, and change the data frame as .xdx, I mean the vertical form, and I'm calculating the log function as here. After that, I'm calculating the difference on that and using the function sd is for standard deviation. So let's run it. So when you run it, this program will got the answer that 1997 of for January it is giving nothing value, but to 1972 for January it is giving value something. Okay, it is the called the applying the function of calendar by month of like this. Or you can estimate the annualized volatility as well. So to estimate it, you should have to first import on library. It is called quant mode library. You should have to import. So my quant mode library is already installed on that, and after running it is already now in active state. So get samples, it turns on functions, so it will be created the polarity calculations for that. So for more details you can come at here, double quotations mark. Yeah, get samples you got. So press it enter to get the more helpful result here. Sorry, it is given the documentation. Yeah, get sample, it is the loading and manage data from multiple source. It is the form of that. So my data is pg. I'm taking the data from 2016 to 9 to 2017 927. Okay, and auto assign is true. So let's run this thing. We got the time. Now pg dataset is now I considered, and the close, when it's closed my volatility is something. Now I want to calculate the mean that each and every day when it is the market is closed, it some have value. So what is the mean of that? So my mean is calculating at 71.56954. So if I want to plot the ts dot plot with the close, that when this function is trending, the market will get the thing. So from this plotting the result, you can see that the closing timing in the y-axis and the timing in the x-axis. So you can see for first few days is like 100 days is it is normal, then it is become strip, then it is become strip down, after that it is strip again and strip again, and that part is strip down, after that it will strip up again, like this way. So it is the volatility of for share market data. How to calculate these things, you will get the idea from here. Now in the next video here I will discuss about rolling functions. So role apply you should have to use for that at functions. So calculate the function point and move the next data point like this way. It is called role apply. So on the close, I'm applying that when it is closed for 50 data set and with the standard deviations, and by 3 for each and every 3 values I'm calculating, and alignment from right. These are the functions I'm applying. I'm getting the result of like this. Check out. For each and every 3 values I got the result of volatility of like this. Or you can do the autocorrelations of these functions. So here you should have to remember that ACF, autocorrelation function, you should have to import for that. What does it mean? That autocorrelation is meaning that how two data frame or how two data set is related to each others. To understand that one, we are using the autocorrelation functions. Here the pg data set, you can see it here, that pg data, sorry, it's my pg data. From this pg data actually, um, pg dot open, sorry, pg dot adjust, this one I'm using for making the autocorrelation. So this is the data. So I want to understand what is the autocorrelation of this data. To understand it, we're running this program and we'll get the autocorrelation of these things like this in this data set. Yeah, now zoom it. You can see it is we are using for only one data frame. That's why my autocorrelation is giving in the unique form. So if you deal with the others, so it will give the something else. So we'll see this one in this video only. Now, timing a time series for autocorrelations. So you want to test that autocorrelation is good or not. So to do these things, test box.test I'm importing it here. After that I'm giving the data 3, so you will get how it is happen. And you should have to remember for this thing box.test, that if the p-values obtained it's as small as 0 or it is near to 0, then your significance autocorrelation significance is really good. So let's run it. So when I run it, you got the answer like this, and you got the p-value at the last. So with that data, my autocorrelations value is 0.0545. So it is, I think, not good, because it should have to be less than 0.05, then you can consider it. So for that cases, for my particular cases with that data, it is not so good. Now you can do the partial autocorrelation function as well. I'm taking the partial ACF, I mean a plot of autocorrelation functions with the partially. So I'm considering here with the PG of high this data frame. So let's run it, and you will get the answer up like this. So let's zoom it and see my how the autocorrelation. First autocorrelation is very high. After that it is quite above and below. Above and below is like this way. Okay, it is the correlations. Okay, fine. Up to here in this video, this one only, and in the next video, so far I will go through the others as well. It is very important to understand, and this is the most important, that after autocorrelations we will get to the partial autocorrelation function, which I already discussed, and followed by I will discuss the lagged correlation between two time series data, how the two time series data will be lagged, I mean differences, and determining the detrending the time series. Detrending means if there is a time series data is very high, goes high or goes down, so you should have to make it in flat. How to do this thing? And you should have to do the fitting an ARIMA model as well. So there is the auto regressive integrated moving average model is there. How to fix with that model we'll discuss in the next video. So please stay touch with this video. Please like, subscribe, and share my video, and press the bell icon for more notifications. My all the hope inspirations from you guys. So stay touch with my channel and follow me for queries. You can reach out to me as well. Thank you. Have a nice day.